Good afternoon, everyone. We will start the discussion for week two now. So, basically, what we did in the previous session, we'll be following that outline only. First, we will briefly see some of the concepts that you studied in the previous week, followed by some problem solving sessions. That is the previous year assignment. We'll be solving that. After that, we can address your doubts. So, this week was basically on underground cables, right? So the first thing that we studied was how the underground cables are being constructed. So in that topic, so first as we have the conductor, following the conductor, the immediate layer that we have is of insulation, right? So can anyone of you say what are the desirable characteristics for the insulating materials? It is on the screen also, so we can discuss one by one. So the most common insulating material that we use is of paper, right? So this paper, yes, I think someone raised their hand. You can speak. Does anybody want to speak? Okay. So, so the most commonly used insulating materials for this underground cables is paper. So, due to its advantages of, firstly, it has superior heat conductivity, followed by its ability to withstand higher amount of temperature. So we know that these cables they will be laid under the ground where the we can say environmental factors or condition is harsh. So for that we need that the insulating material it should not melt under high temperature and high pressure. Then it's highly durable, its dielectric strength, and obviously it is a very cheap raw material, very low cost, and also lower electrostatic capacitance. So, due to these desirable features, paper is the widely used insulating material for this underground cable. And mostly these are all mineral based, right? We had seen in the lecture. And for that, resin is often being added while impregnating this paper because of its advantage that it does not allow the formation of air voids, which is very crucial. So, can anyone tell me what is the problem if air voids are formed in the cable? Why are we concerned? Let there be the formation of air voids. What threat does it impose to us? Britika Debarma shares you have YouTube channel. Yeah, you can watch the live recorded videos. Last week, a video I have not uploaded. I'll upload after today. Actually, I was traveling, so I was unable to do. So this week and last week video I'll upload by from today evening, and you can also access the slides, the presentation slides, also PPT slides. They are shared in the Drive link. So both the slides and the recorded sessions on the YouTube you can access anytime. Okay, coming back to the discussion as I was asking, so what is the problem if there are air voids inside the cable? Anyone? Because this air void formation we have repeatedly studied during this week. So This question is quite relevant, right? Why are we so much concerned? So I'll give you some time to think, or maybe by the end of today's lecture or next week, maybe you can tell me why these air voids are a threat to the final finished cable. Then, second thing comes the thickness of the insulation. How to decide what thickness of the insulation you're going to keep. So this depends on mechanical and the electrical requirement of the cable that you are constructing. So for the electrical requirement, it basically depends upon the voltage level, and for the mechanical requirement, for the lower voltage cable, we consider the mechanical requirement, whereas for the higher voltage cable, we consider the electrical requirement while deciding the insulation. So here as it is written, the low voltage cable less than 1 kV, so their insulation is decided on the basis of their mechanical requirement, and for the higher voltage level, the thickness it is governed mainly by the electrical requirements. Then after the insulation, we have the sheath, right? So it is anyone why after insulation why do we need the sheath? So basically, so that we do not allow any moisture to seep into the cable structure or reach the conductor basically. So hence over the cable insulation we have the sheath, metal sheath basically, and metal is used because any other organic material, they are not we can say impervious to moisture. Any other organic material, it will let the moisture seep in, but metal will not. Then coming to we had two types of material available with us. One was lead sheath, second was aluminum sheath. So we'll compare the properties of these two materials as a sheath. So the first advantage that we saw was uh, lead sheath. The manufacturing process is very easy. Second, they have high flexibility, and the corrosion resistance is also higher. But the disadvantage that we mostly face for lead is because of its specific gravity and low mechanical strength. So for that, what we do, we go for alloys of lead with other materials such as tin or bismuth to handle these disadvantages. But after this lead sheath, what we discovered that aluminum sheets, they have much greater mechanical strength than lead material. They are low weight. Sorry, there are some network issues. Yeah, the YouTube link is, I think, shared by NPTEL with you, right? Hello, I'm not getting week 0, assignment 0 in account. Can you please send link? So basically, Alok, I don't have this authority to control the assignments. For this, maybe you can mail to the course instructor or the uh, instructor for the TA which are for the course. So there are basically two type of TAs, course TA and PMRF TA. So I am PMRF TA for the doubt clearing. I don't have access to these assignments and all. So maybe you can mail the course instructor or the course TAs. They may help you for that. And the YouTube link, sorry, yes, as I was asking, I think it may have been already been shared with you, right? The Drive link and YouTube link. Okay, next we will see the solid versus the pressurized cable. So basically, the paper insulated metal sheathed cable, they are classified into two types: solid or belted as we say them, and pressurized cable. So the solid cable here, they are basically designed for lower atmospheric pressures. So these solid type cables, their pressure does not go beyond the atmospheric pressure, and sometimes it may even fall below the atmospheric pressure level. So for that, there may be some void formation, but the cable, and when there will be void formation, the cable may break down due to the electric stress. So hence these are basically used for lower voltages up to 33 kV. Then pressurized cable. Here for pressurized cable we use two types of material. Either they can be oil or gas, right? So which one has more advantages, or which one is more preferable in pressurized cable? Oil pressurized cables or gas? Anyone? We have two types of pressurized cables, right? Oil and gas. But which among these is preferred or has advantage? So for oil cables, we need the presence of oil reservoirs, while for gas, no such reservoirs are required, and hence we can say this is more suitable. Then coming to this belted cable, so this belted cable, each core will have a insulation like this. Let's say it is a three core cable. So each core has its own insulation, and again, the, after individually, another layer of insulation is there forming this belt structure. Then we had this external pressure cable. These are used for very higher voltage and they are expensive. So since here steel is used here, so they are robust, we can say, but again, these are very costly. Then the next thing that we studied was effective resistance. So we are calculating the effective resistance of the cable considering various factors. And what were those factors? DC resistance, skin effect, proximity effect, sheath loss, and armor loss. So briefly, we'll discuss these one by one. For the DC resistance, we are considering the temperature effect basically. We see that if the DC resistance, the maximum temperature, uh, it increases by maximum of 20%, then the resistance which was at T equal to 20 degrees centigrade. So here we see that this 2% basically additional is increased to account for this trending. And additionally, if you're considering multiple core cables, then it may additionally increase by further 2% more. Then we are considering the skin effect also, proximity effect, sheath loss. So basically, due to this circulating currents, these may lead to the sheath losses in the cable. Then we had yes, bonding basically. So we want that both ends should be bonded. Otherwise, we saw that it may lead to very high voltages in case of short circuit. So we uh, bond basically both sides so that we allow the flow of circulating current. We allow the flow of circulating current basically to avoid this. And again, if you are allowing the circulating current means it will lead to losses. So what we do, we are cross bonding as you may have seen in the lecture. Basically three will be there and similar to the transposition. So alternately after some distance this first will act as second and second will be acting as three. Similarly likewise two, and again it will be something like this. So similar to transposition, we go for cross bonding. Then next we had studied about armor loss. So this armor loss, it may occur both due to eddy current or hysteresis losses. So we'll solve some problems from the previous assignment now. So I request you to keep your calculators with you. The first question, it is visible, right? So it says that a single core cable, which is 2.5 kilometer long. So I have L equal to 2.5 kilometer and has an insulation resistance of 400 mega ohm. So if the conductor diameter is 4 centimeters, the conductor diameter is 4 centimeters and the insulation thickness is 3 centimeters. So calculate the resistivity of the dielectric rho in the cable in rho per meter. So you may try yourself once for 1 minute maybe. I'll give you the time. You remember the formula for resistance, right? It is R is equal to rho 2 pi L ln R2 by R1. So what is this R2? Hang on. R2 will be the conductor plus the insulation thickness, right? So what will be R2 here? Conductor radius plus the insulation thickness. So what is the radius of the conductor here? The radius of the conductor is in the question, right? Anyone? It is 2, right? Here diameter is given as 4 cm. So radius is 2 plus the insulation thickness is 3. So total R2 becomes 5 cm, right? Now you know the value of R2, you know R1, you know L, you know R, so you can calculate rho, right? You can type in the chat box or unmute. So anyone, what is the answer here? So rho will be R times 2 pi L. So L is in kilometers. We need to convert it into meters because the dielectric is asked in terms of ohm per meter. So what is the answer, anyone? This will come around something 6.8 10 to the power 12 ohm meters. So it will be D, right? Then the next question, for a three-phase transmission system of 765 kV, the core radius is 5 cm and the outer radius is 0.4. It will be also cm. This meters. This is cm. The maximum dielectric stress on single core cable is E max or G max. What is the formula for this? Anyone? This V by R ln R by R, where the small r is inner, capital R is outer. So can you calculate now with this formula? Okay, what is the value of a V here? What I'll put? Amrit, Mayuresh, Debika. I want any one of you to please unmute and help me. What should I put for V? Anyone? So this is in three phases, 765 kV. So we have to put per phase, right? So this will be like 765 by root 3. Then your core radius is 5. It is asked in meter. Maybe you can convert this into meter. ln r, sorry, it is 0.4. Anyone? Do you have your calculators with you? So this will come around something as 4248 kV per meter. Option C. Next is voltage stress in underground cables is maximum at conductor surface and minimum at sheath. Minimum at conductor surface and maximum at sheath. Same at the conductor and sheath or zero at the conductor as well as on the sheath. So this is the conductor. Then this is the sheath here. So let's say this is E1, E2, E3, E4. So what will be the relation? So which is correct? So we know the stress it is maximum near the conductor, right? And it is minimum near to the sheath. As you move away, the stress will decrease. Then the maximum and the minimum stress for a single core cable is given 40 kV and 10 kV. So if the conductor diameter is 2 cm, find thickness of insulation and operating voltage. So here you know Gmax is 40 kV per cm. This is RMS. Gmin is 10 kV per cm RMS, and the conductor diameter is 2 cm. Find the thickness of the insulation and operating voltage. So if you remember, Gmax is, we saw previously, right? V by R, ln R by R. That is near to the conductor. And what is G min? It will be near to the sheath. So this will be V by R ln R by R. So if I take the ratio, G max by G min, it will come as R by R. So here, what is capital R, what is small r? We need to find this out, right? So G max is 40, G min is 10, then what is small r is given? Diameter is 2 cm, so this is 1. So implies your r is equal to 4, or the insulation thickness is 8 cm. So from here, again, so this is small r plus t is 4 cm, small r is 1 cm, so t is 4 minus 1 is 3 cm. The next, what we need to find? We need to find the operating voltage. So this, you can calculate either from this formula or this formula. So here V will be J max times R ln R upon R. So all these values you know, right? So if you substitute all this, you get this as 55.45 kVs. So the option is option B. Is this clear? Okay, next question. So a single core cable, 45 kV, 3 phase, has conductor diameter 2 cm, and a sheath of inside diameter of 10 cm. So it is desired to reduce the maximum stress by using two intersheath. So determine the peak voltage on second intersheath. So uh, what are the two methods for making stress same? We saw right near the conductor the stress is more, and as we move towards the sheath the stress is less. So to manage that we have two types of method or two ways out, right? So one is this intersheath grading, and another one, anyone can you recall? It was grading, right? So here we know for intersheath you can see uh, by using we have here use of two intersheaths. So we make these ratios as equal, right? So let's say this ratio is equal to some alpha. So if we multiply these three ratios, so what we will get d1 d2 d divided by d1 d2 is equal to alpha cube. From here you can get d by d equals alpha cube. This is fine, right? So from here you have the conductor diameter as 2 cm. So d by 2 equals alpha cube. From here you get and this capital D is also already known, right? Inside diameter is also 10 cm here it is given. So here I get alpha as cube root, which is basically cube root of 10 by conductor diameter 2. So if you do this you get around 1.71. So once you know the alpha from relation 1, you know d1 by d was alpha. So what will be d1 is alpha times d. So basically 1.71 times 2. So it will be 3.42 cm. Then second again d2 by d1 is alpha. So d2 is alpha times d1. So again you get d2 as 5.85 cm. Now what we'll do, we need to calculate the voltages, right? So using this formula, G max It was in terms of R, so d by 2 plus again d1 by 2 ln d2 by d1 plus d2 by 2 ln capital D by d2, that is equal to V, and what is this value of V we will put here? Maximum, right? So 45 kV is 3-phase. So first we consider it into line to neutral. Then this is RMS. So to convert into maximum, multiply by √2. So this will convert your RMS to max. So all these values you know here. So from here you can get the Gmax as 12.1.54 kV. After you get the Gmax, you can calculate V1 max, right? So what will be right here? V1 max will be Gmax d by 2 ln d1 by t. Gmax sheath 1 S1 will be V minus V1. Similarly, V2 max will be Gmax d1 by 2 ln d2 by d1, and Vs2 max will be V max S1 minus V2 max. Clear? So if you calculate this, this will come around 30.22 kV, and this will be around 19.06 kV. Here V1 max will come as 6.52 kV, and V2 max is something around 11.15. Where is this? Is 11.156 kV. So the answer here will be VI is 2, it is 19.06. So the first option. So for intersheath grading, you need to remember two relations. देखो ये maximum stress का relation you know from previously. For intersheath you have two conditions. First is the ratio. Basically you have to, let's say this was a conductor, This is between sheet 1 and sheet 2, and this ratio has to be equal. Second relation, what you need to remember is this one. Between, so S1, it is lying between the conductor and the first sheet. So it will be conductor maximum minus this one. Similarly, S2, it is lying between S1 and the V max S1 minus the second sheet. Now moving to next. So single core cable working on 45 kV three phase, conductor diameter 2 cm, and sheath inside diameter 10 cm, basically previously what the same as previous. So it is desired similarly to reduce the maximum stress by using two intersheaths. To find out the ratio of maximum stress without and with intersheath. So here we had calculated with intersheath, the Gmax was 12.154. Gmax width is 12.154 kV per cm. kV per cm. Now Gmax without. So what is G? G is V 45 root 3 into root 2, then R 2 by 2 basically, R into ln 5 by 1, right? So this will come out as 22.83 kV per cm. Let me verify this once. 45 divided by root 3. Yeah, so this will be 22.3, and you need the ratio of without and with. So without by with is 22.83 divided by 12.154. So it will come around as 1.878. So option D. Now the next question. The purpose of sheath in cables is to provide strength, provide insulation, prevent moisture, or reduce capacitance. What is the answer, anyone? Amrit, Mayuresh. Amrit or Mayuresh, anyone? You can type in the chat box or you can unmute. Why do we use this sheath in cables? It was to prevent moisture, right? That's why we were using metal here instead of organic. Okay, next question. So a single core cable, it has three layers of insulation with dielectric constants 5, 3.5 and 2, and has conductor radius of 1.5. So assuming that all three metals are worked at same maximum potential gradient, determine the safe working voltage of cable. So inner and outer radius and maximum are given. So what do we need to do here? Basically, Gmax, it is given as 45 kV per cm, and we have, so here what you know the value of ER, the dielectric constant, basically epsilon R1, R2 and R3. So these four are known. So from these relation and D also you know, the conductor radius is 2 cm, so diameter is 3 cm. So from first one, ER1 is 5 times 3, ER2 is 3.5 times D1. So D1 will be 4.286 cm. Then similarly from here, D2 will be ER2 D1 by ER3, which is 3.5 times 4.286 divided by 2. So this times 3.5 by 2 is 7.5. So you get D2 as 7.5, D1 as 4.86. And the sheath radius is given 5 cm, so diameter is 10 cm. So for the safe working voltage means again maximum. So for the maximum Vmax, we get as Gmax d by 2 ln d1 by d. plus d1 by 2, no, ln d2 by d1 plus d2 by 2 ln d by d2. So you know the value of d1, d2, capital D, everything is known here. So the value of Gmax is also given, 45 kV per centimeter. By substituting everything, you will get this as 126.586 kV per cm. So option A. Next question. So the capacitance of a 3-core belted cable, they are measured and found to be as, so you know we are conducting two set of experiments here. So first one is 3 conductors are bunched together and the capacitance between these 3 conductors bunched together and the sheath is 12 microfarads. So this is basically first case is, the first case is basically this. If you remember the diagram, so in this point all 3 conductors are bunched together and you are measuring the capacitance between this and the sheath. So this is, so here it is given as 12 microfarad. So 3 CS is 12 microfarad. So this is 4 microfarad. Then in the second experiment, between a conductor and other two connected together to the sheath. So here basically we see that the conductor, sheath and the third conductor, they are clubbed together as a single, and we have the first conductor here, let's say conductor 1. So between here there will be CC, here there will be CC and one self. So this translates to, so it is 2 times C plus CS. Previously CS was 4 and this is found as 10. 10 equal to, so CC is 3 microfarad. So find the capacitance of each core to neutral. So Cn will be 3Cc plus Cs. Basically, if you remember, so this was Cs, this is Cc. So we convert this delta to star. So CS, CS and CS, and while converting delta to star, this comes as 3 times. So this is your sheath or neutral point. This is your core. So you can see core to neutral, that will be this or this or this. So hence you get this as 9 plus 4 is 13. Then next question, 22 kV 3 phase 50 Hz line 3.3 kilometer is using 3 single core cables. Each cable has core diameter of 3 cm and thickness of insulation is 1 cm. Permittivity of dielectric is also given. So find the charging current. It is very simple. Here D is 3 cm. If we add the thickness here, so it will be 5 cm. So for C cable, basically 0.024 times L epsilon divided by so 0.024, 3.3, 2.7, 5 by 3 into 10 to the power minus 6 is here, into 10 to the power minus 6 farad, but you get it, otherwise it is microfarad. So you will get this as 0.964 microfarad. Then the charging, I charging is omega C Vp. So omega is 2 pi f C Vp. So 2 pi 50, capacitance is 0.964 into 10 to the power minus 6, and it is how much, 22 kV. So here you get the charging current if you solve this as 3.85. So again here capacitance is given and power loss is given. Determine dielectric loss. So you know IV, if it was perfectly capacitive, then I must have been leading by 90 degrees, but it is not. So this is the loss angle, this is your phase angle. So here the loss is given as 82.1 kilowatt, that is equal to omega c vp square sin delta. So here we get 22.1, 253, 2 by 50, capacitance is 5 nanofarad, voltage is 765 kV, sin delta. So solving this, you get delta as 15.5 degrees. Next one, the insulation resistance of a cable 20 km long is 1 mega ohm. Two cables 20 km long and 10 km are connected in parallel. What is the resistance of the parallel combination? So we know R is inversely proportional to the length of the line. So we know a 10 km you want. Firstly, it was 1 for 20, 10. So you get R2 as 2 mega ohm. Then parallel R is 3 mega ohm. Then ratio at which the minimized dielectric condition R by R will take place. It will take place basically when R by R is E, and E is nearly 2.7. Okay. So the previous assignment is solved for today. Any doubt you have? Amrit Sagar. Am I audible? Okay, so it was clear the questions that we solved today, or any doubt if you have. Okay, so did you solve the previous week's assignment 1? The assignment 1, you have registered for this course or not? Exam. Like, will you be giving the examination for this course at the end? अच्छा, रजिस्टर करने से फिर अगर आप एग्जाम दे रहे हो देन असाइनमेंट ग्रेड होगा। ठीक है, मतलब मैं असाइनमेंट का मार्किंग उसी हिसाब से होता है, इसीलिए मैं पूछ रही थी अगर आप एग्जाम। तो अभी जैसे 2 घंटे का टाइम स्लॉट पूरा होने में टाइम है, तो कोई क्वेश्चन, अगर किसी क्वेश्चन में डाउट है तो आप पूछ सकते हो, नहीं तो ठीक है, विल क्लोज दिस सेशन अदरवाइज। Okay, you can leave the meeting.